Hello students, today in this video we are going to take up a new chapter, refraction through lenses, which is chapter number 6 of your physics book. So topics to be discussed in this video are given below. So without taking too long, let's proceed towards our first topic. First topic is thin lenses. So lens basically is a transparent medium having two refracting surfaces, and both surfaces are spherical in nature. You can see that if I and lenses are of two types, first is convex and second is concave. Now if I draw a convex lens, it appears like this, and if I draw a concave lens, it appears like this. So convex lens is, now in the convex lens you can see that both surfaces are bulging outward, whereas in the concave lens both surfaces are bulging inwards. Now convex lens is also called as converging lens, and concave is also known as diverging lens. We will see why convex lens is known as converging lens and concave lens is known as diverging lens later in the video. Now we can see that first we will take up convex lens. So convex lens both surfaces are convex, which means bulging out, and these types of lens converge the light rays. Converge means bring closer. Let's see how this happens. You can see that there are two rays. This is your ray 1 and this is your ray 2. So you can see that if both rays are going in this particular direction, this ray 2 is going in this direction and ray 1 will go in this direction if this lens is not there. So you can see that both rays are going away from each other. So now due to this lens you can see that this first ray comes in this direction and it is bent in this particular direction, and ray 2 which is going in this particular direction is bent in this particular direction. So you can say that these both rays are going away from each other, but due to the convex lens both these rays come closer and meet at a point. So this is known as converging of rays, which means if two rays are going away from each other and they are made to come closer, this process is known as converging. So now I think you people will appreciate that point, that the name of the convex lens can also be given as converging lens. So having understood about the nature of the convex lens, let us discuss the types of the lenses. So convex lens is basically of three types. First is double or biconvex lens. So in this convex lens you have both surfaces which are bulging outward. Now second type is plano-convex lens. In this, one surface is bulging outward and other surface is a plane surface. And third is concavo-convex lens. So you can see that this surface is bulging outward and this second surface is bulging inward. So bulging inward represents concavo, and bulging outward represents convex. So we conclude that since this lens has one surface bulging outward and one surface bulging inward, so its name is concavo-convex lens. Now proceeding further, we will take up convex lens. So in convex lens both surfaces are concave. These lenses diverge. Diverge means spread the light over a large area. So let us see how this diverging occurs. Now you have two rays, this is your ray 1 and this is your ray 2, ray 1 and ray 2. So now you can see that these rays are coming closer to each other. Suppose this lens is not there. If this lens is not there, which means these two rays will meet at this particular point. But due to presence of this concave lens, these rays when emerge they become parallel to each other, which means they will never meet. So अभी आप देख सकते हैं कि कॉन्केव लेंस ने जो दो रेज मिलने जा रही थी उनको एक दूसरे से दूर कर दिया, तो मतलब स्प्रेड कर दिया. सो दैट इज़ वाई concave lens is called as diverging lens. So let us discuss how this diverging occurs. Now you have this ray 1, it is going from air to glass. This lens is made of glass, so it is going from air to glass. Air is rarer medium as compared to glass, so this ray is going from rarer medium to denser medium, which means it will bend towards normal. So this is your normal, this line is your normal, straight line is your normal, sorry, this straight line is your normal. So instead of going in this particular direction, it will bend in this particular direction. And again, when this ray strikes at this surface, you have to draw a normal here also. And since this ray is going from glass to air, so it will bend away from the normal, so it becomes parallel to the principal axis. Now same can be said about the second ray. This is your ray 2, it is going from air to glass, which means going from rarer to denser medium, so it will bend towards normal. If when this ray strikes at this particular surface, we will draw another perpendicular, that is normal. And again, since this ray is going from glass to air, so it will bend away from the normal, so both rays become parallel. And now you can see that these rays cannot meet. So concave lens acting as a diverging lens, it is diverging the rays which are coming closer. Now having discussed the nature of the concave lens, let's discuss its type. So again, as same as convex lens is of three types, similarly concave is of also three types. First is biconcave lens. In this, both surfaces are bulging inward. Plano concave, you can see that this surface is bulging inward and this is a plane surface. Now convexo concave, you can see that this surface is bulging outward and this surface is bulging inward. So one surface is bulging outward, that is convex, and second one is bulging inside, that is concave. So this lens is called as concavo convex lens. Now we will take up some technical terms related to the lenses. So first term is center of curvature. Before going in this topic, I would like to tell this is a bit difficult topic, so pay greater attention to this topic so that you people may understand this topic throughoutly. Now we know that each lens, each surface of a lens is a part of a sphere. Suppose this is your sphere 1 and this is your sphere 2. Suppose I cut apart this, cut apart from the sphere, and इस part को मैं यहाँ पे बना देता हूँ, इस part को मैंने कट करा और इसको यहाँ पे बना दिया. सो अब देख सकते हैं ये हमारा एक कॉन्वेक्स लेंस हो गया है. अब आप इस पार्ट को मैंने इस तरफ लगाया था, तो ऑब्वियसली इस अब देख सकते हैं ये जो ये वाला हमारा सरफेस है, ये इस स्फीयर का पार्ट है, विच मीन्स इसका इस स्फीयर का सेंटर यहाँ कहीं होगा. सो वैसे ही इस सरफेस का सेंटर यहाँ कहीं पे होगा. सिमिलरली अगर जो मैं इस सरफेस की बात करूँ, सो इसका सेंटर इस साइड कहीं होगा, बिकॉज ये सरफेस इस स्फीयर का पार्ट है. सो इसका सेंटर इस जगह कहीं होगा. The same thing is depicted in the figure. You can see that this is your surface 1 whose center of curvature is lying at this point, and this is your surface 2 whose center is lying in this direction. Again, if we discuss the same concept in concave lens, you have this is your first surface and center of curvature is lying in this direction. This is your second surface and center of curvature is lying in this direction. अभी डिफरेंस आप देख सकते हैं कि जब हम कॉनकेव के पहले सरफेस की बात करेंगे तो उसका सेंटर ऑफ कर्वेचर उसके ऑपोजिट रह रहा है, जब कॉन्वेक्स की बात पहले सरफेस की बात करेंगे तो वो उसी डायरेक्शन में रह रहा है। सो ये बेसिक सा एक डिफरेंस है बिटवीन द सेंटर ऑफ कर्वेचर ऑफ कॉन्वेक्स एंड कॉनकेव लेंसेज। Okay, having discussed about the uh, having discussed about the uh, lying of the center of curvature of both convex and concave lenses, let us now we will define the center of curvature of both the. So now center of curvature is defined as the center of the sphere from which refracting surface is made. So suppose this is your sphere and उससे एक रिफ्रैक्टिंग सरफेस मैंने ये बनाया हुआ है. Suppose this is your sphere and this refracting surface is taken here. So इस surface का जो center होगा वो इस refracting surface के लिए center of curvature का काम करेगा. I hope this is clear to you. Now you can see that since this surface is taken from this whole sphere, so center of this sphere, that is C2, is called the center of curvature for this surface. Now similarly, this surface is made from this sphere, so center of this sphere, that is C1, is called center of curvature for this surface. So I think you have understood what actually center of curvature is. अगर जिसको मैं हिंदी में डिफाइन करूँ तो बेसिकली कोई रिफ्रैक्टिंग सरफेस जिस स्फीयर का पार्ट होता है उसके सेंटर को हम लोग यहाँ पे सेंटर ऑफ कर्वेचर बोलते हैं. सो आई होप यू हैव अंडरस्टूड दिस टॉपिक properly, center of curvature. Now let us move to another topic. Now we will discuss radius of curvature. Since I have already defined center of curvature, so if this is your if this point is your center of curvature, then this particular distance is called as radius of curvature, which means distance between optical center and center of curvature is called radius of curvature. Suppose you have a convex lens here, so optical center is a midpoint of the convex lens, so optical center is always represented by O, and let's your center of curvature is C1, which is lying at this point. So this distance is known as radius of curvature. So basically distance between optical center and center of curvature is called radius of curvature. So we can see that we have two radius of curvature in both convex lens and concave lens. This is your radius of curvature 1, this is your radius of curvature 2, that is R1 and R2. So you have two radius of curvature R1 and R2. These radius of curvature can be equal, they may not be equal. Now we will discuss optical center. So as I have already told you, optical center is basically the midpoint of the lens. So you can see that here are two refracting surfaces. This is your first refracting surface and this one is your second refracting surface, they are joining. So this particular point, this point O is called as optical center. So you can see that this picture I think is clear. You can understand radius of curvature from this picture clearly. So distance between this O and this C2 is known as radius of curvature. So this is your R2 and this is your R1. Now from the figure, one important thing is there, that for convex lens this first radius is known as radius R2, and for concave lens this first radius is known as R1. This difference lies just because uh, in convex lens, this is your first refracting surface, and its center of curvature is here, so which means this is your first radius of curvature, that is r1. When we talk about convex lens, since this is first refracting surface, its center of curvature lies in this direction, so this is your r1. सो अगर जो मैं सिंपल कंक्लूजन ये करूँ कि जब हम कॉन्वेक्स की बात करते हैं तो उसका फर्स्ट रेडियस ऑफ कर्वेचर इस डायरेक्शन में होता है। जब हम बात करेंगे कॉन्केव लेंस की तो इसका फर्स्ट रेडियस ऑफ कर्वेचर इस डायरेक्शन में रहता है। नाउ वी विल discuss another important topic, that is principal focus. So principal focus, as you have learned in the class 9th also, that principal focus is for concave and convex mirrors. Now we will discuss the principal focus for the convex and concave lenses. So since both lenses have two refracting surfaces, so they have two center of curvature, two radius of curvature. Similarly, they have two principal focuses. So first we will talk about first principal focus. This is another difficult concept, so pay attention to whatever I am saying. Now I have written the definition as rays starting from this point or appearing to go this point become parallel after refraction. So आप रे डायग्राम से देखते हैं हम लोग, यहाँ पे एक पॉइंट है प्रिंसिपल एक्सिस पे f1. आई डोंट नो अबाउट प्रिंसिपल फोकस दिस, अगर जो इस f1 से रेज चलेंगी, सो आफ्टर रिफ्रैक्शन दीज रेज बिकम पैरेलल. सो अगर जो ऐसा होता है देन f1 इज कॉल्ड एज प्रिंसिपल फोकस 1 और फर्स्ट प्रिंसिपल फोकस. अगेन आई रिपीट, देयर इज़ अ पॉइंट f1. मैंने एक बेसिकली पॉइंट सिर्फ अज्यूम करा हुआ है, वो ज़रूरी नहीं कि प्रिंसिपल फोकस हो. फिर वहाँ से कुछ रेज चलेंगी, अगर जो वो रेज रिफ्रैक्शन के बाद पैरेलल हो जाती हैं तो f1 हमारा प्रिंसिपल फोकस होगा, अदरवाइज़ नहीं. आप एक रैंडम पॉइंट को पहले सेलेक्ट करो, देन डिफाइन करने के लिए हम ये मानेंगे कि वहाँ से चलने वाली रेज आफ्टर रिफ्रैक्शन दे बिकम पैरेलल टू द प्रिंसिपल एक्सिस. ओके, नाउ look in the figure for the concave lens. You can see that rays are coming in this particular direction. This is your ray 1, ray 2, ray 3 and ray 4. If this concave lens is not there, these rays will meet at point f1. But since there is concave lens, so these rays will become parallel to each other. So basically now we will define principal focus. अगर जो मैं हिंदी में बोलूँ, सो प्रिंसिपल फोकस बेसिकली हमारा प्रिंसिपल एक्सिस का वो पॉइंट है जिसकी तरफ आती हुई किरणें, आती हुई रेज रिफ्रैक्शन के बाद दे बिकम पैरेलल टू द प्रिंसिपल एक्सिस. सो दैट पॉइंट इज कॉल्ड एज प्रिंसिपल फोकस फर्स्ट फॉर द कॉन्केव लेंस. आई अगेन रिपीट, एक पॉइंट प्रिंसिपल एक्सिस पे ऐसा है जिसकी तरफ आती हुई लगने वाली रेज refraction के बाद they will become parallel to the principal axis. That point is called as principal focus first for the concave lens. Now having understood about the first principal focus, we will go to the second principal focus. Now you can see that these two rays are coming parallel to the principal axis, and after refraction they are meeting at a point f1. Again in this figure, two rays are coming parallel to the principal axis, and after refraction they become divergent in nature, which means these two rays are going away from each other. So अभी हम इतना predict कर सकते हैं कि since they are going away from each other, so इधर ये इस तरफ, since these rays are going in this direction, so यहाँ पे इस direction में लेंस के इस साइड ये कभी भी मिल नहीं सकती. So these two rays will appear to meet at a point lying on the principal axis. So these 2 points are called as principal focus for convex and concave lenses respectively. So now we will define these points. For first we will define for the convex lens. So आप देख सकते हैं parallel rays आ रही हैं and they are meeting at a point on the principal axis. So I will define second principal focus as rays coming parallel to the principal axis meet at a point after refraction. This point is called as second principal focus of convex lens. Now we will define second principal focus for concave lens. Rays coming parallel to the principal axis seem to meet at a point lying on the principal axis. This point is called second principal focus for the concave lens. Now I hope you understand about the first and second focus of both the lenses. If you have any confusion, you can ask me through WhatsApp or any other medium. Now we will discuss focal length. So basically focal length is an easy topic because it is basically the distance between optical center and a principal focus. So since both lenses have two principal focuses, so both lenses have two focal length also. So total we have 4 focal length. Now one important thing is that you can see that for convex lens first focus lies in this direction. So for convex lens first focus is considered as positive, whereas for concave lens first focus lies in this direction, so it is taken as negative. So as discussed in the class 9th, basically हम मिरर के इस साइड की सारी चीज़ें पॉजिटिव होती हैं एंड मिरर के इस साइड की सारी चीज़ें नेगेटिव होती हैं. तो आप देख सकते हैं यहाँ पे प्रिंसिपल फोकस है तो मिरर के लेंस के इस साइड हुआ. सो दिस first principal focus for the concave mirror is negative, whereas for convex lenses it is positive. So focal length basically depends upon RI of the lens and material surrounding it, and second thing on which focal length depend is radius of curvature, and third is wavelength of the incident light.